What if the most important military announcement of the decade wasn't the unveiling of a new aircraft, but a signature hidden inside a government funding bill? No dramatic rollout, no roaring engines across a desert runway, just billions of dollars quietly redirected toward two classified programs that could redefine the balance of air power for decades to come. While much of the world focused on daily headlines, officials in Washington were making a decision that carried a far deeper message. The United States was no longer preparing for yesterday's conflicts. It was accelerating toward a future many believe is arriving faster than expected. For years, military analysts have argued that technological superiority gave the United States a comfortable advantage in the skies. Stealth bombers, fifth-generation fighters, precision-guided weapons, and an unmatched global logistics network created the image of an air force with no equal. The assumption became almost automatic. If a crisis erupted anywhere on Earth, American aircraft would eventually dominate the skies. That belief shaped defense planning for an entire generation. But assumptions have a way of aging faster than technology. Across the Pacific, rival military powers invested heavily in advanced radar systems, long-range missiles, electronic warfare, and their own next-generation combat aircraft. Every year, the gap appeared slightly smaller than before. What once looked like an overwhelming lead slowly transformed into an increasingly competitive race. The question inside the Pentagon was no longer whether America remained powerful. The real question was how long that advantage could be maintained without changing course. That change began to appear not through speeches, but through spending. Deep inside defense appropriations, lawmakers approved an extraordinary increase in funding for two programs already considered among the most important in modern aviation. One was the B-21 Raider, America's next-generation stealth bomber. The other was the F-47, the future air superiority fighter expected to succeed the legendary F-22 Raptor. On paper, they looked like separate projects. In reality, they represented two halves of a much larger strategy that was only beginning to reveal itself. The size of the investment surprised even seasoned observers of defense budgets. Billions of dollars were allocated not simply to continue development, but to accelerate it. That distinction matters. Military procurement often stretches across decades, slowed by engineering challenges, budget negotiations, and shifting political priorities. Yet this funding carried a different tone. It suggested urgency. It suggested that waiting was no longer viewed as an acceptable option. The story becomes even more remarkable when looking beyond the numbers. These aircraft were never intended to exist merely as symbols of technological prestige. They are being designed for a strategic environment unlike anything previous generations faced. Future conflicts are expected to unfold against sophisticated air defense networks capable of tracking multiple targets, disrupting communications, and denying access to entire regions. Winning such a fight would require aircraft that can survive, adapt, and coordinate in ways older platforms simply cannot. Long before additional funding arrived, the B-21 Raider had already moved beyond the concept stage. Inside secure facilities operated by Northrop Grumman, production was no longer theoretical. Engineers, technicians, and assembly workers had transformed years of digital models into flying aircraft. The Raider completed its first flight in late 2023, marking the beginning of an intensive test campaign designed to evaluate everything from flight performance to mission systems. Every successful sortie represented another step toward replacing some of the oldest and most valuable bombers in the American inventory. Unlike its predecessor, the B-21 was conceived from the beginning with flexibility in mind. It is expected to carry both conventional and nuclear weapons while operating deep inside heavily defended airspace. Rather than relying solely on stealth as previous generations did, its effectiveness comes from the integration of advanced sensors, secure networking, electronic warfare capabilities, and continuously evolving software. In modern warfare, survival depends as much on information as it does on physical invisibility. The Raider is being built around that reality. Yet despite impressive technological achievements, production remained one of the biggest challenges. Building stealth aircraft has never been simple. Specialized materials, precision manufacturing, and rigorous quality standards make every airframe extraordinarily complex. Increasing production without sacrificing quality requires enormous investments not only in factories but also in skilled workers, supply chains, and manufacturing infrastructure. That is precisely where the new funding began to reshape the program. Instead of allowing production to grow gradually over many years, additional government investment aimed to expand manufacturing capacity almost immediately. Facilities already operating in California prepared for faster output, while Northrop Grumman committed billions of dollars of its own corporate investment to strengthen long-term production capabilities. Private industry rarely spends that kind of money without confidence that demand will continue for years. The company's decision spoke almost as loudly as Congress itself. Behind closed doors, discussions inside the Department of Defense reflected another emerging concern. The original acquisition objective envisioned approximately 100 B-21 Raiders entering service over time. For many years, that figure appeared sufficient. After all, the United States had operated only 20 B-2 Spirit bombers, each capable of missions that few other aircraft on Earth could accomplish. But strategic conditions were changing faster than earlier forecasts anticipated. Recent operational experience reinforced that realization. The limited B-2 fleet remained one of America's most valuable military assets, capable of penetrating defended airspace and delivering precision strikes over intercontinental distances. Every deployment demonstrated both the bomber's extraordinary capability and its scarcity. 20 aircraft simply could not provide unlimited global coverage. Each mission highlighted an uncomfortable reality. Maintaining deterrence across multiple regions demanded greater capacity than legacy fleets could provide. As defense leaders evaluated future scenarios, conversations gradually shifted away from replacing existing bombers one for one. Instead, planners began asking whether a significantly larger force would be required to support simultaneous operations across multiple theaters. Those discussions extended into Congress, where lawmakers requested further analysis of long-term bomber requirements. The debate itself revealed something important. America was no longer thinking only about modernization. It was reconsidering the overall scale of its strategic air power. While attention focused heavily on the Raider, another program quietly advanced toward becoming the centerpiece of future air superiority. Known as the F-47, this sixth-generation fighter is expected to succeed the F-22 Raptor, an aircraft that has dominated discussions of air combat for more than 2 decades. Replacing such a platform is no ordinary task. The Raptor established a reputation for unmatched maneuverability, stealth, and combat effectiveness. Building something significantly better requires more than incremental improvement. It requires an entirely different philosophy. Unlike previous generations of fighters, the F-47 is expected to emphasize adaptability as much as raw performance. Engineers are developing the aircraft around modular systems capable of accepting new hardware and software throughout its operational life. Instead of locking technology into fixed configurations for decades, future upgrades could be integrated much more rapidly. Digital engineering techniques, including virtual aircraft replicas that mirror real-world performance, promise to shorten maintenance cycles while accelerating innovation. The aircraft becomes less like a finished product and more like an evolving platform. What makes this especially significant is that both the B-21 Raider and the F-47 are evolving during the same strategic moment. They are not isolated modernization efforts competing for resources. They are increasingly being viewed as complementary pieces of a unified vision for future warfare. One extends American reach deep into contested territory. The other protects control of the skies while coordinating with advanced networks and emerging weapon systems. Together, they begin to resemble components of an entirely new operational architecture rather than simply 2 advanced aircraft. As more details emerged, one question started echoing throughout defense circles. If these programs are moving faster than expected, receiving extraordinary funding, and attracting unprecedented industrial investment, what exactly are American planners preparing for? That question leads far beyond budgets and aircraft specifications. It points toward a changing geopolitical landscape where technological leadership may determine not only who wins the next conflict, but whether that conflict can be deterred before it ever begins. Morning arrives quietly over the California desert, but inside Northrop Grumman's secure production facility in Palmdale, there is no sense of routine. Long before sunrise, engineers gather around digital displays while technicians move between unfinished airframes hidden behind layers of security that few outsiders will ever witness. Every measurement is checked repeatedly, every panel fitted with microscopic precision, because the smallest imperfection could affect the aircraft's ability to survive in the world's most heavily defended airspace. From the outside, it looks like another manufacturing plant. Inside, it is one of the most important construction sites in modern military aviation. The pace inside those buildings has changed dramatically. Production schedules that once stretched comfortably into the future are now being compressed, forcing suppliers, engineers, and assembly teams to rethink years of planning. Additional funding has allowed new tooling, expanded manufacturing space, and investments in workforce training that would have taken much longer under a traditional procurement timeline. For the people building the B-21 Raider, the mission is no longer simply to produce an advanced bomber. It is to deliver operational capability before strategic circumstances demand it. Military officials rarely use dramatic language when discussing procurement, yet their actions often reveal far more than their public statements. Accelerating production is never just about saving time. It reflects an assessment that tomorrow's security environment may arrive sooner than expected. Every month gained in manufacturing translates into earlier deployment, earlier pilot training, and earlier operational readiness. In strategic planning, those months can become the difference between reacting to a crisis and preventing one. The Raider's testing campaign mirrors that urgency. Each flight generates enormous volumes of performance data collected by engineers monitoring every aspect of the aircraft's behavior. Test pilots push the bomber through carefully planned profiles designed to validate systems that remain largely classified. Behind every successful mission stands a network of analysts comparing real-world performance against sophisticated digital models. Every flight reduces uncertainty, bringing the aircraft one step closer to frontline service. Meanwhile, hundreds of miles away inside government offices in Washington, another process unfolds with equal importance. Congressional committees examine classified briefings, review industrial capacity reports, and question military leaders about future force requirements. Public debates often focus on how much money is being spent, but behind closed doors the conversation revolves around a different issue entirely. Is the United States moving fast enough to maintain its strategic advantage over the next 20 or 30 years? That question has become increasingly difficult to answer with confidence. For decades, American defense planning benefited from a relatively comfortable technological margin. New aircraft entered service well ahead of comparable foreign designs, allowing military planners to think in long development cycles. Today, that margin appears narrower. Advances by competing powers have compressed the timeline, forcing decision-makers to accelerate innovation rather than rely solely on past achievements. The B-21 program illustrates this shift perfectly. Instead of designing an aircraft that remains unchanged throughout its service life, engineers have emphasized adaptability from the very beginning. Mission software can evolve. Electronic warfare capabilities can improve. New sensors and communication systems can be integrated without redesigning the entire aircraft. Rather than reaching a technological peak at the moment it enters service, the Raider is intended to keep growing more capable over decades of operation. The same philosophy shapes the development of the F-47, although its mission is entirely different. If the Raider is designed to penetrate enemy defenses, the F-47 exists to dominate the airspace surrounding those operations. Air superiority has always been the foundation upon which nearly every successful military campaign depends. Without control of the skies, transport aircraft become vulnerable, naval forces operate under constant threat, and ground troops lose critical protection from above. Maintaining that advantage against increasingly sophisticated opponents demands something beyond incremental improvement. Engineers working on the F-47 are not simply designing another fast fighter with stealth characteristics. They are attempting to create an aircraft capable of functioning as the central intelligence node within a much larger combat network. Information collected by one platform can be shared instantly across multiple systems, allowing aircraft, satellites, drones, and command centers to operate as a unified force. Speed and maneuverability remain important, but information dominance may prove even more decisive. This transformation reflects one of the biggest lessons learned from recent conflicts around the world. Modern warfare is no longer determined solely by which aircraft carries the best weapons or flies the fastest. Victory increasingly depends on who can detect threats first, process information faster, and coordinate responses before an opponent even understands what is happening. In that environment, software becomes almost as valuable as the aircraft itself. Digital engineering has therefore become one of the defining features of the F-47 program. Engineers maintain virtual versions of the aircraft that continuously mirror the condition of their real-world counterparts. Every flight, every maintenance action, and every system update contributes new information to these digital twins. Instead of waiting for mechanical problems to appear unexpectedly, technicians can often predict maintenance requirements before failures occur. The result is higher readiness, lower long-term operating costs, and aircraft that spend more time flying rather than sitting inside maintenance hangars. Behind these technological advances lies an equally significant industrial transformation. Building sixth-generation aircraft requires manufacturing techniques very different from those used only a decade ago. Automation, advanced composite materials, artificial intelligence-assisted quality control, and highly integrated digital supply chains have become essential components of production. Factories themselves are evolving into sophisticated technological ecosystems where software and manufacturing operate side by side. That evolution also explains why private industry has invested billions alongside government funding. Defense companies recognize that these programs extend far beyond individual contracts. The factories, production methods, and engineering expertise developed today will shape aerospace manufacturing for generations. Every investment strengthens an industrial base capable of supporting not only current aircraft but future systems that have yet to leave the drawing board. As both programs gained momentum, military planners began exploring how they might operate together rather than independently. Future conflicts are unlikely to involve isolated aircraft carrying out separate missions. Instead, bombers, fighters, drones, satellites, electronic warfare platforms, and precision-guided weapons are expected to function as interconnected elements of a single operational system. Success depends less on the individual performance of one aircraft and more on how effectively every component communicates and supports the others. One emerging concept attracting significant attention involves integrating next-generation stand-in attack weapons across multiple platforms. These advanced munitions are being developed to survive inside contested environments where traditional missiles might struggle against increasingly capable air defenses. Rather than relying on overwhelming numbers of weapons, future strike packages may depend on fewer but far more intelligent systems capable of adapting during flight. In this vision, the B-21 Raider and the F-47 become launch platforms within a much broader ecosystem designed for highly contested battle spaces. The deeper analysts examined these developments, the more obvious a pattern became. None of these investments appeared isolated. Production expansion, digital engineering, modular architecture, advanced networking, and next-generation weapons all pointed toward a coordinated transformation rather than a collection of separate modernization efforts. The United States Air Force was not merely replacing aging aircraft. It was redesigning the very way air campaigns would be fought. Yet perhaps the strongest indication of changing priorities came not from aircraft specifications, but from strategic planning itself. Increasingly, official discussions referenced operating in environments protected by sophisticated anti-access and area denial systems. These defensive networks combine long-range missiles, advanced radar, electronic warfare, and integrated command structures intended to keep opposing forces at a distance. Penetrating such defenses requires more than stealth alone. It demands constant adaptation, resilient communications, and seamless coordination across every domain of warfare. As military planners refined future operational concepts, one geographic region repeatedly emerged in strategic discussions. The Indo-Pacific had become the primary focus of long-term defense planning, driven by the rapid modernization of military capabilities throughout the region. Vast distances, contested maritime routes, and increasingly sophisticated air defense systems presented challenges unlike those faced during previous decades. Any future operation there would test every assumption about modern air power. The B-21 Raider and the F-47 were therefore being shaped by scenarios that extended far beyond traditional bombing missions or air-to-air combat. Together, they represented an attempt to preserve operational freedom inside environments specifically designed to deny it. Every engineering decision, every production investment, and every funding increase reflected preparation for conflicts that military leaders hope will never occur, but believe they cannot afford to ignore. As the production lines accelerated and development programs gathered momentum, one reality became impossible to overlook. These aircraft were never intended to stand alone. They were pieces of a much larger strategic puzzle whose full picture was only beginning to emerge. And as that picture became clearer, attention shifted toward the nation whose rapid military modernization had fundamentally changed the calculations inside the Pentagon. The competition was no longer about building better airplanes. It had become a race to define the future of air warfare itself. The deeper defense planners looked into the future, the clearer the strategic picture became. It was no longer enough to ask whether the United States possessed the world's most capable aircraft. The more pressing question was whether those aircraft could still operate freely in an era defined by sophisticated surveillance networks, long-range missile systems, cyber warfare, and rapidly evolving artificial intelligence. Air superiority, once taken for granted, had become something that would need to be earned all over again. That realization transformed military modernization from a long-term ambition into an urgent national priority. Much of that urgency centered on the Indo-Pacific, where vast distances and increasingly capable military forces have reshaped nearly every American defense calculation. Operating thousands of miles from home presents enormous logistical challenges even in peacetime. In a conflict, those challenges multiply as aircraft must contend with layered air defenses, electronic attacks, and precision-guided missiles capable of threatening bases that were once considered secure. Future operations would demand not only superior technology but also resilience, flexibility, and the ability to adapt faster than an opponent. Among the many developments influencing these calculations was the rapid progress of China's aerospace industry. Programs associated with advanced combat aircraft, including the J-36 and the J-50, signaled that Beijing was investing heavily in technologies once viewed as uniquely American strengths. While many details surrounding these aircraft remain uncertain, their existence alone demonstrated how quickly the global military aviation landscape had evolved. The assumption that technological leadership would remain uncontested had quietly disappeared. For decades, American defense strategy benefited from time. New aircraft could be developed carefully, tested extensively, and introduced gradually because no rival appeared capable of closing the gap quickly. Today, that luxury no longer exists. Every year of delay gives competitors additional opportunities to refine their own capabilities, expand production, and integrate new technologies. The pace of innovation has become almost as important as innovation itself. That explains why recent funding decisions carried significance beyond their dollar value. The billions directed toward the B-21 Raider and the F-47 were not simply purchasing additional hardware. They were buying time, or more accurately, reducing the amount of time needed to place new capabilities into operational service. In modern strategic competition, delivering an aircraft 2 years earlier may prove more valuable than adding incremental performance improvements years later. Yet perhaps the biggest misconception surrounding these investments is the belief that they revolve around aircraft alone. In reality, neither the Raider nor the F-47 represents the final objective. They are platforms within an expanding ecosystem that includes satellites, autonomous collaborative aircraft, secure communications networks, electronic warfare systems, cyber capabilities, and precision-guided munitions. Remove one element and the system becomes weaker. Connect them all together, and they create something far greater than the sum of their individual parts. Imagine a future operation unfolding over enormous distances. Long before pilots approach hostile airspace, satellites and surveillance systems begin collecting information. Artificial intelligence rapidly processes enormous quantities of data, identifying potential threats and recommending courses of action. The B-21 Raider penetrates defended territory while remaining connected to a network extending far beyond the horizon. Nearby, the F-47 maintains air superiority, coordinating with autonomous systems that expand awareness far beyond what any single pilot could achieve. Every platform contributes information. Every decision strengthens the effectiveness of the entire force. Viewed from that perspective, the recent acceleration of both programs takes on an entirely different meaning. Washington is not merely replacing aging bombers and fighters. It is constructing the architecture of a future battlespace where information flows continuously between every participant. The aircraft become command centers as much as weapons, linking sensors, decision-makers, and strike capabilities into one seamless operational network. Air warfare itself begins to evolve into something fundamentally different from the campaigns of previous generations. This is where the true story emerges. For years, public discussions focused on which country possessed the faster fighter, the stealthier bomber, or the more advanced missile. Those comparisons still matter, but they no longer capture the full picture. Military superiority in the coming decades may depend less on the performance of individual machines than on the ability to connect thousands of systems into a single intelligent force capable of adapting in real time. The B-21 Raider and the F-47 are among the first major platforms designed from the ground up for that new reality. Seen through this lens, the funding increase stops looking like an isolated budget decision. It becomes evidence of a broader transformation already underway inside the United States Air Force. Production expansion, digital engineering, modular software architecture, industrial investment, advanced manufacturing, and integrated operational concepts all point toward the same destination. Every piece supports the others. Every decision reinforces a single strategic objective. The twist is that these aircraft may never achieve their greatest success in combat. Military history often celebrates battles won through overwhelming force, yet the most effective weapons sometimes accomplish their mission without ever firing a shot. Deterrence has always relied upon convincing potential adversaries that aggression would carry unacceptable consequences. A bomber that can reliably penetrate defended airspace, paired with a fighter capable of dominating contested skies, changes calculations long before any conflict begins. Their greatest value may lie in preventing wars rather than fighting them. That possibility explains why industrial capacity matters almost as much as the aircraft themselves. Factories capable of sustaining production send a strategic signal of endurance. They demonstrate that capability can be expanded if circumstances demand it, reassuring allies while discouraging rivals from believing temporary advantages might shift the balance permanently. In this sense, assembly lines become instruments of national strategy just as surely as the aircraft rolling off them. Behind every advanced composite panel, every software update, and every classified sensor package stand thousands of people whose names rarely appear in headlines. Engineers solving problems that have never existed before. Technicians spending countless hours ensuring microscopic tolerances are met. Test pilots accepting risks that accompany every new flight. Airmen preparing to operate and maintain aircraft whose full capabilities remain known only to a select few. Technology may define the tools of modern warfare, but people continue to define its outcome. Years from now, historians may look back on this period not as the moment when two new aircraft entered production, but as the beginning of a broader shift in military thinking. They may see it as the point when air power evolved from collections of independent platforms into deeply interconnected combat systems capable of operating across every domain simultaneously. If that assessment proves correct, the B-21 Raider and the F-47 will be remembered not simply as remarkable aircraft, but as symbols of an entirely new era. The future remains uncertain, and no amount of funding can guarantee strategic success. Technologies evolve, geopolitical realities change, and today's advantages inevitably face tomorrow's challenges. But one message has become unmistakably clear. The United States has decided that maintaining air superiority in the decades ahead will require more than preserving past achievements. It demands faster innovation, stronger industrial capacity, and a willingness to rethink how military power is built from the ground up. Some stories begin with the roar of engines breaking the sound barrier. Others begin with quiet decisions made around conference tables, hidden inside budget documents that few people ever read. This story belongs to the second category. The billions invested in the B-21 Raider and the F-47 are more than financial commitments. They are a declaration that the race for the future of air power has already begun. And somewhere behind secured hangar doors, beneath bright factory lights and layers of secrecy, that future is no longer being imagined. It is already taking shape, one aircraft at a time.